Now let's continue. So in the last video, we already talked about the basic setting of fixed order quantity model by assuming that both the market demand realization and also the lead time are perfectly known. Okay, that's the basic assumption. Now, let's take one step further. If we relax this assumption by assuming that demand is not perfectly known, although we have some information about demand based on historical data, and also we still keep lead time is constant, as I show here, all right? Now, then if we relax the assumption as what I just mentioned, how it will actually impact the procedure of using fixed order quantity model to maintain the inventory management. So we all know that in fixed order quantity model, right, we have two key questions to clarify. The first question is, how much should I order each time, all right, when I call my supplier in order to get some new amount, all right? The second key question is, when should I reorder some new amount each time, all right? So if we relax the assumption that I just mentioned, all right, then there's a good news and there's a bad news here, all right? The good news is that the EOQ amount, basically the amount that I should order each time from my supplier, is still following exactly the same equation that we mentioned within the basic setting. So EOQ amount will not be affected, all right? Even if demand is not perfectly known, demand has some uncertainty, but we do have some information related to how this demand realization will be distributed, all right? So EOQ amounts will not be affected. Keep that in mind, very, very important, all right? However, the bad news is that, okay, when demand is uncertain, you have to do some adjustment for your reorder point. Basically, when we should reorder, okay, at what level we should reorder some new amount, this reorder point has to be adjusted, okay? You may still remember that within the basic setting, all right, the reorder point equation, basically just reorder point equals to D bar times L, okay? We detailedly talk about this specific equation when we go through slide 23 in the last video, right? R equals to D bar times L. However, here, as I said, if we relax this assumption, so here the equation for reorder point will be adjusted. How we adjust it? Very simple. The first element showing in this adjusted, equation of reorder point is still D bar times L. It doesn't change. Okay. However, we need to further consider another part, which is called safety stock conceptually. What means by safety stock? Very easy. Basically here, since your demand is uncertain, although we have some information about demand distribution, right? In order to prevent the stockout situation, due to this uncertainty, we have to prepare a little bit more compared to the case that we exactly know what is the demand will be. All right, so that's why here, that's the purpose why we need the safety stock. Basically, we just need a little bit more amount in order to, get rid of the uncertainty, the stockout situation, according to that uncertainty. All right, but how we calculate this additional amount, okay, which we call safety stock? Very easy. Let's continue. Here, I list the equation about calculating the safety stock. Let me briefly illustrate it. So as you can clearly see here, the safety stock equation is extremely simple. Safety stock equals Z times sigma DLT. So as I just mentioned, basically here, we assume that we do not exactly know the demand realization. However, instead, we at least know some historical data about the demand realization distribution, right? So here, we assume that demand realization distribution is following a normal distribution, such that we know the corresponding mean and also the standard deviation. However, we do not exactly know what will be the demand realization. All right, so based on that assumption here, all right, so if further I tell you what is the corresponding probability of not having stockout situation, then we can easily use Z table to check the corresponding Z value. All right, since all of you guys already took that course before, I will not recap this process. However, if you are still unclear about how we basically use probability of not having stockout situation to guess the corresponding Z value, feel free to let me know. All right, so this will be the first element within the safety stock equation. All right, the second element is sigma DLT. So sigma DLT here represents during lead time. All right, as I just said, basically in the information context, normally we will tell you the standard deviation of daily market demand realization. However, don't forget that within this safety stock equation, the standard deviation that we want is for the whole lead time period instead of just the daily standard deviation. But there's an interrelationship between the standard deviation during the lead time and also the standard deviation of daily. All right. So this will be the corresponding equation. Very simple, right? So sigma DLT equals to square root of sigma D squared times this L. What does L mean? This L basically represents the lead time. Okay, so this equation also is extremely straightforward. All right, so once you know the standard deviation of daily market demand and also corresponding lead time, you can simply calculate the corresponding sigma DLT and put this value into this equation. And then once you know the Z value, no matter I tell you directly or you check it by using the Z table, you can simply get the Z value and multiply these two things to get the corresponding safety stock. Okay, and once you get the safety stock, you further, add this part into this corresponding reorder point equation such that you can get the updated reorder point. Okay, the reason that we do this safety stock because here we relax the assumption, right? In the original case, the market demand is perfectly known. However, here, when market demand is not perfectly known and we know some distribution about the market demand, then we do this adjustment in order to basically update the reorder point. Very easy, all right? Now, here, let's look at this example. So example 3 is still based on example 2 that we just mentioned within the last video, all right? And as you can clearly see here, all right? So basically, the EOQ amount doesn't change. It's still, you see, 75 units. We don't even list the corresponding equation since we already listed all of the details within example 2 slides, all right? Now here, suppose that, the lead time is still constant. However, for the demand part, right, we do not exactly know what is the market demand realization. However, at least we know the average demand is 18 units per week with the standard deviation of 5 units. All right, so that's why here, see, we do not exactly know the demand realization. However, we know some demand information, which is basically the demand distribution information, right? And the lead time is still keep constant at 2 weeks, all right? If the information context tell us this type of the information, we know that, okay, EOQ amount will not be affected, okay? That's a good part. However, for the reorder point, we have to do some adjustments. Here, let's say if we further tell you that basically the management decides to have a 90%, not having stockout situation, basically the cycle service level, the same meaning here, all right? Then what would be the corresponding safety stock that we have to further prepare in order to get rid of the stockout situation? Very simple, as you can clearly see here, right? Safety stock equals to Z times sigma DLT. All right, and 90% probability of not having stockout situation. If you go back to the Z table, you can clearly see that corresponding to the 1.28 Z value. If you're unclear about this step, please let me know. All right, and for the sigma DLT, how you get this sigma DLT? All right, very easy. Now, so basically, if we go back to based on this specific equation, right? Here, the information context already tell you sigma D is 5 units. Right, is 5 units, all right? So sigma D is 5 units showing here, basically within this equation, okay? And the lead time is what? Lead time is 2 weeks, is 2 weeks. Here, the unit that you use is based on week, so that's why we can directly use week here. They are consistent, that's good enough, all right? So that's why here, we plug in 5 for sigma D and plug in this 2 weeks for basically L. And then you plug in these 2 values into this equation, you will get the corresponding sigma DLT based on this specific equation, all right? And you can double check. Basically, the result should be 7.07, okay? After you get both Z and sigma DLT, you can calculate the corresponding safety stock, which is 9.05, or you can just keep the corresponding integer value, which is 9 units, okay? And in example 2, without demand uncertainty, we know that the reorder point should be 2 times 18, which is 36. However, here, since market demand has some uncertainty, right? Because you do not exactly know what will be the market demand realization. Instead, you just know some distribution of the market demand realization based on the historical experience. So that's why here you need to further basically prepare some safety stock. And the safety stock amount is already calculated as what we just detailedly mentioned, which is 9 units. So that's why you further add up this 9 units when you try to set up for the reorder point, which is 45 units shown here. Okay, so the process here is still very standard. Okay, but keep in mind when demand is not perfectly known, what dimension will be adjusted, what dimension will not need to be adjusted. That's it. All right. Now let's continue. Now let's move to fixed time period model. All right. So we detailedly compare fixed order quantity model and fixed time period model conceptually in last video. All right. Here, let's talk about more about fixed time period model. So first of all, the key characteristic of fixed time period model is that the time interval period for review is fixed. All right. So for instance, as a manager or inventory manager, you will only review your inventory at the beginning of every month or in the middle of every month or at the end of every month. All right. During this period, you are not actually look over the inventory amount. All right. Now, that's actually quite different from the fixed order quantity model because, within fixed order quantity model, as we said, you have to, look over your inventory amount normally every day, right? So that's why fixed order quantity model is a continuous review system. However, here, as you can clearly see, fixed time period model is a periodic review system. That's actually a very important difference between two models, okay? And within fixed time period model, we say that basically the period itself is already fixed and normally it's given by the management. All right. However, the order amount each time when we decide to reorder is flexible, can be changed. All right. Which is also very different from fixed order quantity model because within fixed order quantity model, all right, the order amount itself is fixed. However, the review time is actually triggered by the reorder point level, which indicates that this is flexible. All right. So here within a fixed time period model, since the interval period for review is already fixed, for example, at the beginning of every month, according to management experience. All right. So we don't actually have to calculate and deal with that dimension, such that the only dimension that we need to calculate is the order amount each time when we review. However, in order to get the order amount that each time you review, all right, you need to first calculate the corresponding target inventory level. But how we get the target inventory level within the fixed time period model? Very simple. Now, let me get to this specific equation. All right. Now you can see that T equals to D bar times, this P plus L and plus safety stock for protection interval. So here we view the protection interval as P plus L. I will detailedly talk about what this means here for P protection interval. All right. But you can clearly see that the equation tells you that T equals to D bar times the protection interval and also plus safety stock for protection interval. So structurally, if you look at this equation, this is very similar as the reorder point equation, right? Within the fixed order quantity model. However, the key difference here is that within the fixed order quantity model, when we calculate the reorder points, right? Here, okay, we basically prepare reorder point for the lead time, right? This safety stock is for the lead time. This D bar times L is also for the lead time. However, if we go to the fixed time period model, when we calculate the target inventory level, all right, all you're calculating is not just for lead time, all right? You are actually calculating target inventory level for the whole production interval, which is P plus L. What is the reason why actually when we calculate the target inventory level here, although we are using the same structure, right? D bar times a period plus safety stock for a certain period, all right? Here we need to incorporate more time. We call it production interval here. The reason is very simple. We need some inventory amount within our factory only because we want to get rid of the stock out situation, right? Within fixed order quantity model, as we detailedly talk about, the only possible reason that you have stock out situation is during the lead time, right? Because you order some amount, however, those amount is still within the transition. So the stock out situation can happen during the lead time by using the fixed order quantity model. However, due to the characteristic of fixed time period model, you are not actually, review your inventory amount during both the regular time and also the lead time, right? So the stockout situation can happen during both periods. That's why when we set up this inventory amount, target inventory amount, in order to get rid of this stockout situation, you have to incorporate both periods. That's why you use P plus L instead of looking at L itself. All right. Okay. And that's why when we calculate target inventory amount, right? You see, this equals to D bar times this whole period, P plus L instead of just L, right? When we calculate the safety stock for production interval, the structure shown here, okay, is exactly the same as what we just did, right? When we calculate safety stock within a fixed order quantity model. However, the only difference here is that basically here, we calculate safety stock for the whole production interval, basically P plus L this whole time, right? Within the fixed order quantity model, when we calculate safety stock, we only calculate safety stock for the lead time itself, okay? So what is the corresponding difference mathematically? Very simple. Here, you see, you still use Z times the corresponding sigma P plus L, all right? So getting Z value itself is exactly the same, all right? Once you know what is the corresponding probability of not having a stockout situation, you can use Z table to get the corresponding Z value. That's the same process. However, when we calculate corresponding sigma, since we are calculating the sigma for the whole production interval, here we need to incorporate both, the regular period and also the lead time. So sigma P plus L equals to basically the daily market demand standard deviation, and then times the square root of P plus L instead of only L itself. Okay, that's the only difference here. And once basically I give the corresponding information context, you can simply calculate the corresponding sigma P plus L and then plug it back into the specific equation to get the corresponding safety stock. Okay, and you then further, get the corresponding value within the whole equation when we try to calculate the target inventory level. All right, and once we get a target inventory level, don't forget what is our final target. Very simple. We want to know what is the exact amount that we should order from our supplier, right? Each time when we periodically review our inventory system. Okay, how you get that amount? Very simple. You already know your target inventory amount, right? You use amounts minus your current inventory amount. That difference will be the amount that you should order from your, let's say, supplier. All right. Now, if we still go back to the example that we repeatedly use during this whole, chapter. All right. Let me directly look at the corresponding T calculation process. Okay, because the other things are exactly the same. All right, so you can clearly see that when we calculate this, target inventory level, all right, you see that basically equation is D bar times the basically whole production interval, P plus L, and also we need to calculate safety stock during this production interval time, right? So you can see that D bar is still 18, okay? However, P plus L basically is 6 weeks in total. We tell you that basically the regular time is around 4 weeks and the lead time is 2 weeks. That's why in total is 6 weeks. Okay, so you can simply use 18 times 6 to get the first element when we calculate target inventory level. All right, and when we calculate the safety stock, okay, the only difference showing here, you see, still the 90% cycle service level still give you Z value, which is 1.28, which is exactly the same as you can see within example 3. Okay, exactly the same. All right, now when we calculate sigma P plus L, the only difference is already showing within this equation, okay? So when we calculate, we're at a point within fixed order quantity model, as I repeatedly said, basically we only care about the lead time, but here we care about the whole production interval, okay? And the whole production interval here is 6 weeks, okay? So that's why here you see, you still use this 5, okay? For the weekly standard deviation, to represent sigma D. However, you times the square root of P plus L, which is 6 weeks in total. That's why you see the sigma P plus L is 12.25. Okay, use this 12.25 back into the calculation process of the safety stock process, and then you get the corresponding safety stock amount. Okay, and then once you have the safety stock amount, okay, you plug into this target inventory level equation to get the final, target inventory level. Okay, suppose I tell you that currently we have, for example, 20 inventory on our hand. Then what is the corresponding amount that I should order? Very simple, use 124 minus 20. So basically, this time, when it reaches reorder review time, you should reorder 104 units because your target level is 124. Your current level is 20. So you have to reorder that difference, which is 104 units from your supplier. Okay, so that's it for this specific chapter. And you can clearly see that, we conceptually and quantitatively compare both fixed order quantity model and the fixed time period model. Keep that in mind, which is quite important. If you have any question, feel free to let me know. Thank you.